Welcome back, ladies and gentlemen. We're going to take a look at example 1 from the Trig package. And from the Trig package, what we have is an identity we need to prove. Cosine x plus tan x all over sine x is equal to 1. So the hints that we have to train you is you deal with the more complicated side. Now the complicated side, sometimes it's very obvious, and sometimes it's not. The main goal is just to pick and choose which side. Now the right-hand side here, some students would argue this is the more complicated side. But to make this one look like this, that's a little tough. So most students will choose the left-hand side. Now, I like doing it this way. In other textbooks, people maybe do a T-chart. But I like saying the left side, because it's kind of like the check that we're trying to make the left side look like the right side, or vice versa. Our second tip that we tend to ask you to try to use, change things in terms of sine and cosine. So cos x and sine x, they're already terms of sine and cosine. But this tan x, or tangent of x, using the quotient identity, I can rewrite that. Which is sine x over cos x all over sine x. Hopefully I'm going slow enough so that you can see it. But then, how do we add fractions? And there's a typo here. It's not supposed to be plus. That's my fault. It's a multiplication question. So it's cos x times tan x over sine x. That's my fault. So for example 1, hopefully you caught that. Can someone just double check from the package, from the class here? Is it cos x times tan x over sine x? Thanks, yeah, Devin. So my apologies at home. I did a copying error. I put a plus sign by accident, and then it's not solvable. So it's supposed to look like this. So then the cos x divides up this cos x. And this sine x divided by that sine x, which equals to 1, which is of course equal to the right side. So we've already proven the identity. So one more time, ladies and gentlemen, double check my copying of the questions on the chalkboard. There wasn't supposed to be a plus sign. Everyone okay with that? Let's try example B. Hopefully, I'm going to copy this one down. Hopefully someone will make sure I'm doing this right. I think this is example B. This time, let's get some class participation, if that's okay. Any volunteer want to help Mr. Chen choose a more complicated side? Which side is more complicated, left side or right side? Dinesh?
Right side.
Right side, I would choose. Thanks, Dinesh. Different volunteer to continue, try to change things in terms of sine and cosine. Anything there we can change in terms of sine and cosine?
You can make tan x sine x over cosine.
That's correct. What Jasmine said is change that tan x in terms of the quotient rule. And you don't have to use colors, but I'm trying to teach it. Sine x over cos x. And ladies and gentlemen, just try things out. What's frustrating is you always kind of want to get the right answer. So in some sense, with a lot more experience, you'll see it quite easily. But even if you try it and it doesn't work out, then you just do something else. That's what's frustrating, that you don't like doing. But if you play video games, it's like, Dark Souls, Demon Souls, Bloodborne, tough crap. Anyways, back to this. What we have is this answer here. So we got 1 over cos x minus sine squared x over cos x. 1 minus sine squared x over cos x. And it seems like we're stuck. And again, some of you have been paying attention that we don't manipulate the actual identity. But if you remember from your tool set, and I'll write this in red, we have the Pythagorean identity. And we can actually use derivations of this Pythagorean identity. What does that really mean? I can actually isolate for sine squared x. And I can also isolate for cos squared x. Watch carefully. Sine x squared x is equal to 1 minus cos squared x. Most students don't need to memorize this. They use the Pythagorean identity to derive this second one. Similarly, can someone help us out in the class? If I isolate for cos squared x, what would that be equal to? Alright?
1 minus sine squared.
1 minus sine squared x. So notice, although for the original question, you don't manipulate this, we can actually use the tool set that's provided for you. And again, most students do not memorize all three. They memorize the first one, the Pythagorean identity, and use that derivation. So some of you can already see this, what I'm trying to do. And again, it's not the only way to do this question, but some of you realize we seem like we're stuck, but 1 minus sine squared x, even though it's equal to the right-hand side, that's why a lot of you realize these are identities. We can go backwards and forward. We can go from left side to right side or right side to left side. Meaning, 1 minus sine squared x is cos squared x. Now some students say, I don't know what to do. So the thinking behind this is very, very similar. It's like x squared over x. Which I think some are already slowly seeing what we're trying to do. This answer actually looks like cos x, because it divides out. And what do you know? We stop here? Absolutely, because the right side looks like the left side. Technically, this is what you're supposed to do. Since the left side equals right side, or right side equals left side, therefore, identity proven. But this is just a formality. Okay, so I'm just trying to show you one example. And I should have actually done it for that first example. Any question about example 1A or 1B? Probably just do one more. Is that okay? One more? And then, don't get me wrong, we'll continue working on it. But on at home, ladies and gentlemen, if you're watching this, we'll definitely do them in the synchro class on Wednesday and Thursday. So the last one we're going to do is question C, I think. And again, feel free to pause the video. I should have said at the beginning. As you attempt these lessons, the package. Hopefully I copied that down correctly. We have sine squared x over 1 minus cos x equals 1 plus cos x. And again, one more time, ladies and gentlemen, we're not manipulating, like moving this over to the other side, we're not rearranging, right? You have to choose one side and try to make one side look like the other. Okay? So I think most of you will choose the left-hand side. And what do we got? We have sine squared x, 1 minus cos x. This one actually can be done many ways. Jasmine, you want to try?
The numerator can be 1 minus cos, do you call it to the power of 2?
You just say, so you say exactly how it's written, right? So 1 minus cos squared x.
Okay.
You just say exactly this. You don't say, that's why when we're being taught like in elementary or school, like in grade 9, like we don't say x to the power of 3, we say x cubed or x to the third. We actually drop the word power, we drop the word exponent. Okay? But don't worry. Sorry, so you wanted to make that 1 minus cos squared x?
Yeah.
Okay, so don't get me wrong, ladies and gentlemen at home. This is one way to do it, and there's different ways of showing that numerator.
And then you can do 1 plus cos x times 1 minus cos x.
So just to explain what Jasmine's doing in class, she's taking that numerator, 1 minus cos squared x, she's being suspicious, which is good. That's a difference of squares. So 1 plus cos x, 1 minus cos x. Notice I'm trying to illustrate the identity replacements, but this is not like, this is just math, right? That's why at home, ladies and gentlemen, you gotta have to remember how to deal with factoring and expanding in different squares or perfect squares. And I think everyone agrees that 1 minus cos x, just like our rational pressure unit, divides out. Where'd you get this? The only way you get better doing trig identities is if you actually try to do them, right? So even though you're following along, don't memorize what actually is written. Try to look deeper into the problem of actually how we got there. Okay? So I know I only did the first three, and of course with your help, ladies and gentlemen from class. So A, B, and C. D and E, we'll definitely take them up in the synchro class, and then we can definitely do some more. But again, on your test, this is not on it. It's to help you with your assignment. Your assignment is, in my opinion, really challenging, right? So you might need to think kind of outside the box with your trig identity.